Afternoon, everyone. Thank you to the organizers for the opportunity and for the introduction this morning by Keith to this technique of mass spectrometry imaging that we use, primarily for analysis of the penetration of antiretroviral drugs into key reservoir tissues, but the other domain that I'll talk about this afternoon focuses on looking at the disposition of those drugs in hair strands. So the advent of long-acting injectables has provided a really important new alternative for HIV treatment that exhibits long-term exposure of drug. But, and I should say that the accessibility and use of those tools has continued to grow, but the PK tail associated with these injections remains not well characterized, although we've heard some very important work today to that end. But it can be significant, and there are clinical examples of virological failure among individuals that use long-acting treatment associated with low trough concentrations of both Cabotegravir and Rilpivirine despite on-time injections. So we believe that a non-invasive method for monitoring months-long exposure to drug provides the potential for an important support and identification of individuals who may be at risk for virological failure. We've developed an approach based on IR-Maldesi mass spectrometry imaging, which uses a focused laser to probe 100 micrometer features of hair strands to build a picture of antiretroviral accumulation within individual strands. And each of the pixels in this image to the left represent an individual sampling location corresponding to roughly 8 hours of hair growth. And in this example, the disposition of emtricitabine is mapped in a color scheme that differentiates regions of low exposure in black to higher exposure in yellows or reds. And we can combine the response from these individual strands into a composite profile and then correlate the position along that profile to a point in time based on the average growth rate of hair. And by looking at the relationship between the emtricitabine response in that profile to a benchmarked adherence cut point, we can create a report of adherence behavior in the binary classification shown in the report on the far right. And we have demonstrated the ability to use this mass spec imaging approach for adherence classification, as well as correlation to dried blood spot analyses for oral regimens using directly observed therapy benchmarking, which we've published on for emtricitabine as well as Maraviroc. Now we've applied this approach to long-acting injectables, and we've developed an assay that's capable of looking at the components of Cabenuva in the same measurement. And typically we evaluate 5 plucked strands from an individual. We prefer plucked strands because that provides us with the most recent growth of hair. We evaluate those strands alongside incubated quality control blank strands that are oriented vertically and horizontally during the acquisition. This map here shows cholesterol, which is ubiquitously present in all of these strands, just to give you an idea of where the strands are placed. And then we orient the proximal or root end of the dosed strands to the left of this image, and you can see the disposition of Cabotegravir and the higher disposition of Rilpivirine, which we attribute to increased accumulation in the hair strands based on the physicochemical properties of the drug. Typically, we're evaluating the proximal roughly 2.5 centimeters of these strands. And then we can overlay these distributions with cabotegravir in red and rilpivirine in blue to look at co-localization of these drugs. So we have developed two tools to help us get information from the raw MSI image to a longitudinal profile. The first is called Mohawk, which we use to extract information along single hair strands and radially average the response to drug along the center line of that strand. And then the second allows us to align the individual strand profiles into a composite profile. And here again is where the plucked strand is very helpful to align the proximal end of the strand to ensure that you've got a common reference point. So we undertook a small pilot study in which we collected 5 hair strands that were plucked from participants with undetectable viral loads who were receiving long-acting cab and rilpivirine for HIV treatment at the UNCID clinic. The only exclusion criteria in this study was that no salon-level hair treatment be reported. And among the 18 participants, most identified as either African American or white and non-Hispanic, 61% were receiving injections on an 8-week schedule, and the remainder were receiving their injections monthly. The median BMI was 27.5, and individuals were receiving their median 3rd dose upon return to the clinic, which ranged from either their 2nd to their 7th dose. And the time point at which the samples were collected was a median 58 days after their prior injection. Most of the hair that was collected was of black or brown color, but we were also able to sample blonde and gray hair. So now to the results. We were able to interrogate a median in 86 days of hair growth. And in individuals receiving monthly treatment, this retrospective window provided by MSI was able to identify single and multiple dosing events. So the figures shown here show the profiles of cabotegravir in red and rilpivirine in blue, along with a smoothed profile of each in the thicker lines to help kind of guide your eye, so it's a little bit easier to see the dosing intervals. The x-axis reflects time, either in days or weeks, and is referenced to the time point of their most recent injection. And then for those individuals that were receiving injections on a bi-monthly basis, this retrospective window allowed us to see the entire dosing interval, or for individuals that were transitioning between dosing frequencies, we were also able to capture a good portion of the prior dosing interval as well. The variability that we found in the long-acting cabotegravir and rilpivirine response over the most recent dosing interval was higher on average than the QC standards of the same drugs, as well as profiles of emtricitabine that were evaluated during our Enlighten benchmarking study among individuals that had adherent classification behavior. But it was only cabotegravir in which we found this distinction to be statistically significant. Excuse me. So I wanted to also provide an example of a profile in which there may be some indication that further support or monitoring could be warranted. This is from an individual with high BMI where both low Cabotegravir and Rilpivirine accumulation were apparent throughout the retrospective window of analysis. And in the proximal portion of the most recent dosing interval, there's also at least a suggestion or indication that there may be delayed uptake of Cabotegravir from the most recent injection with respect to Rilpivirine. So just to conclude, we certainly feel that identifying patterns of long-term delivery of both Cabotegravir and Rilpivirine is really essential to optimizing the care of individuals who are using long-acting injectables for treatment, and that this mass spectrometry imaging technique, IR-MALDESI, can provide daily assessment of short-term and long-term changes in the exposure provided by these tools, and potentially be used for long-term monitoring using a sample that can be collected quite easily to prevent virological failure. With that, I'd like to thank you and my collaborators.